Hi friends, welcome back in the series of computer vision. So today we have another case study that is on convolution. So basically today we will get to know a bit in depth about convolutions, right? So again, before starting the video, please do like, share and subscribe, which helps our team to get motivated and that's only we'll be able to create more content on it. So before wasting time, let's start one by one. So first we are importing necessary library. Like for data manipulation we have NumPy, pandas. Then for data set we are using CIFAR10 data set. Then for visualization, of course, we'll be using matplotlib, pyplot and seaborn. Then there is some miscellaneous, like we'll be using the classification report to check the classification matrix of our model. Now loading the data set. So from CIFAR10 we use the load data. Then we are using we are storing it into trainx, trainy, test y. Now data set shape and size, so you can see that we can get the data shape in this manner. So we have the training data like this, we have the testing data, then we have the training data in percentage and the testing data in percentage. So you can see that it is divided into nearly 83 ratio 16 for the training and testing respectively. Now analyzing labels, so label equals to np dot unique train y, so display unique labels. Number of labels equals to length of labels, so length of unique labels we have. Now printing labels, that is all these labels that we have 0 1 2 up to 9, and total number of label we have is 10 according to our data set. Now visualizing the first 10 images in the data set and their labels. So for that n equals to 10, that means we wish 10 images to see. Plotting figure size, that is n for 10 images, and one is we are passing the second parameter. Now for I in range n, so we are plotting subplot for each images, right? CMap, that is a gray, we are passing it. And then the title, so it will print the title of the respective image, right? Then access of, and you can see the plt dot show, so 699411. So these are the label of our data set. That means if you can see that, I can see it as a truck, so truck is labeled as 9. This one also you can see 9. Then 4 we have as an animal kind of thing. One is a car, so of course wherever you will see a car, there is labeled as 1, right? 7 is as horse, and 8 is board, like that. Now train x 0, so you can see that if we get the all the values of this particular image, so we'll get it like that. Now train x dot as type, so we are converting the type into float 32, right? And then reshaping it, our train x, and after reshaping we are same we are doing with the testing data. So now we can see the training data is this and the testing data is this. Now we have the CNN model 1. So to add my point on the HP, so input shape 32 by 32 into 3 channels, so that means there will be layers. So the first layer will be our convolution, that will have number of filter 32, kernel size 3 by 3 as given here. Pooling is 2, padding is 0, stride is 1. Similarly for layer 2 convolution, number of filters 64, then kernel size 3 by 3. Activation function ReLU we will be using, pooling 2, padding 0, stride 1. Then we have layer 3, that is neural network, dense layer unit 64, softmax output unit 10. So from tensorflow.keras.models, so import sequential. From tensorflow.keras.layer, import convolution 2D, dropout, dense, flatten, best normalization, max pooling 2D. So here model architecture building, so model 1 sequential, adding batch normalization on the input shape of this. Now adding convolution 2D, filter 32, kernel size, like all these parameter that we pass for our model building, right? Now model 1 dot add max pooling 2D, so pooling size equals to 2. Then model 1 dot add convolution 2D, filter 64, kernel size 3, padding same, activation ReLU. Model 1 dot add max pooling 2D, pool size is 2. Now model 1 dot add flatten. So here you can see model 1 dot add dense unit 64 activation ReLU. So we have the classification layer model 1 dot add dense unit equals to 10 activation softmax. Now from tensorflow.keras.optimizer import Adam, optimizer Adam, model 1 dot compile optimizer Adam loss. We have sparse categorical cross entropy matrix equals to accuracy. And if we see the model accuracy, so model summary, sorry, so you'll get to know that. So this is what we have defined: the batch normalization and these parameters. Convolution 2D, you can see the shape of output and the parameter. Max pooling layer, similarly convolution 2D, max pooling 2D1, flatten, dense and dense 1, right? So total parameter we have this much number, trainable parameter this much, and non-trainable this much. Now model 1 equals to model 1 dot fit passing train test data. Epoch is 30, epoch is 15, that means it will go to 15 iteration. Epoch is 15, that means it will go to 15 iteration. Validation data test x test y, initial epoch equals to 0. So here you can see that till 15 epoch, this is our loss or the validation loss, so that is 18%, which is good because you can see that it keeps decreasing as our epoch going on. Now for epoch 15, so we have this graph. So here you can see that the green one is the training loss and the blue one is the validation loss. So you can see that the training loss is decreasing, but the validation loss is increasing a bit. Now for epoch 15, so again the training accuracy and the validation accuracy. So if we talk about it, so green one you can see that increasing, that means our training accuracy and validation accuracy is kind of at the same rate, right? Now let's compare with the another model, that is CNN model 2. So to add more point on it, so here you can see that again we are passing something input shape same that we had. So if we talk about, so here you can see that input shape is same, but the only change will be parameter in the layer. So layer 1 convolution, number of filter 32, 3x3 kernel size, activation function ReLU, pooling 3, padding 0, stride 1. Now convolution, number of filter 64, kernel same, ReLU 301. And convolution, so you can see that we are activation function we have in as ReLU in all our 3 layers. And the final layer we have neural network, that is dense layer unit 64, dense layer unit 32, dense layer 16. The same we defined here. So till here you know how to do that, but additionally we are using the fully connected layer here. So that is unit 64 activation ReLU, dense unit 32 activation ReLU, unit 16 activation ReLU. So now classification layer model 2 dot add dense unit 10 activation equals to softmax. Now from tensorflow.keras optimizers import Adam. So optimizer equals to Adam model 2 dot compiler compile optimizer Adam loss sparse categorical cross entropy matrix accuracy. So model 2 dot summary. So here you can see that all this we have. Model 2 equals to model 2 dot fit train x train y epoch 5 validation data test x test y, initial epoch is 0. So here you can see that for first 5 epoch what we got, the loss we have is 96%, we can say. For epoch 5 we got the training layer loss and validation loss, both are kind of decreasing. And the epoch 5, if we check the training accuracy and the validation accuracy, both are decreasing. So that means the loss should always be decreased, right? But the accuracy if we are getting increasing, so that means that is it is going towards a good model, right? So let's compare with another, that is CNN model 3. So here we'll be passing some different parameters. So here the first layer is seen, second layer is there, third layer is there, fourth layer is there. So we have added this up to number of filter 128 to 56, and finally the neural network here. So we are again doing the same thing here, fully connected layer. So this time we have 128, 64, 32, 16 and 8. dense unit equals to 10, activation softmax. So tensorflow.keras.optimizer import Adam. So optimizer equals to Adam, lr equals to 0.001, model 3 dot compile. So optimizer Adam, loss, sparse, categorical, cross entropy, matrix accuracy, model 3 dot summary. So here you can see all these. Now model 3 dot fit, train x, train y, epoch 5, validation data, test x, test y, initial epoch is 0. So here all that we have for epoch 5. So we got this training loss, this validation loss. So again this is decreasing, but validation loss started uh, going into upward from fourth iteration, right? So here if we check the accuracy, but of course the accuracy is increasing. That means the deeper network yield better accuracies with same number of epochs, right? So I hope you got the slight idea that how the convolution and how we set all these model building parameters, right? How we add the layers, so you can try with different layers, right? So yeah friend, this was all about it. Hope you liked it, you enjoyed it. If yes, please do like, share and subscribe. We'll be back in the next video. Till then, all the best, have a good time.